Let's take a look at another transformation in this style. T is going to map P2 to R3, and this time we'll be evaluating the polynomial at 3 different places because we got to map to R3. So I'm going to evaluate P of 0, P of -1, and P of 2. Our standard basis for P2 is still 1t and t squared. Our standard basis for R3 is 1, 0, 0, 0, 1, 0, and 0, 0, 1. Oh, sorry, I read that as as rows instead of columns. So in fact, it's 1, 0, 0, 0, 1, 0, and 0, 0, 1. What we want to notice this time is that we're mapping a 3-dimensional vector space to another 3-dimensional vector space. In the previous example, we mapped a 3-dimensional vector space to a 2-dimensional vector space. So in the previous example, we got onto, but we did not get one-to-one. We couldn't get one-to-one. There were too many. We went from 3 to 2. There's going to be some squishing going on here. But in this case, we're going from P2 to R3, a 3-dimensional vector space, to another 3-dimensional vector space. And we're doing it by evaluating each polynomial at 0, -1, and 2. So in this case, our matrix of the transformation will be 3 by 3 because we're going from 3 dimension to 3 dimension. So let's find the standard matrix. This is our standard operating procedure. We need to know about the transformation. We need to get the matrix of the transformation so we can get at the pivots of the matrix of the transformation so we can find some stuff out about the transformation itself. So let's find the standard matrix . Note that when we're finding the standard matrix of T by mapping the basis vectors, the reason this is the standard matrix is that we're using the standard basis. So if I had some wacky basis, basis B, and some other wacky basis for R3, I would make a matrix. It wouldn't be called the standard matrix. It would be called like the B matrix of the transformation. But since I'm using the standard basis, we'll call it the standard matrix. And to do that, we map the basis vectors. The columns of the standard matrix will be the images of the standard basis vectors. So let's plug 0, -1, and 2 into the polynomial 1. When we plug in 0, we get 1. When we plug in -1, we get 1. When we plug in 2, we get 1, because 1 is the only thing that this polynomial will give us. Constant polynomials are the Hodor of polynomials. So now let's plug in 0, -1, and 2 into the polynomial t. So I get 0, -1, and 2. So there's the second column of our transformation. Now let's plug everything in t squared, our second column of our matrix of the transformation. So we'll have 0, -1 squared is +1, 2 squared is 4. The images of the standard basis vectors are the columns of the standard matrix of the transformation. I'm going to call that matrix, as I usually do, A. First column is 1, 1, 1. Second column is 0, -1, 2. And then 0, 1, 4. So here's the standard matrix of T. So we're going to want to know some stuff about this standard matrix, so that we'll know something about the transformation. So let's find the reduced echelon form of this matrix. So 1, 0, 0, 1, negative 1, 1, 1, 2, 4. So the reduced echelon form of the standard matrix is the identity matrix. So that means we have a pivot, first row, first column, second row, second column, third row, third column. So now we notice that T, the transformation, is both injective and surjective. T is invertible because the standard matrix of T is invertible. So we notice lots of things. A, the standard matrix of T, has a pivot in every row. And that tells us that T is surjective. T maps P2 onto R3. Everything in R3 is the image of some vector in P2, some polynomial in P2. A has a pivot in every column. So T is injective. That is, T is 1, 2, 1. So everything in R3 is a unique image, or is the image of some unique vector in P2. So there will be solutions, and those solutions will be unique. So every vector in R3 is the image of some polynomial in P2. So this is a row, this is a span question. The columns of A span R3. The injective part gives us uniqueness. So every vector in R3 is the image of one polynomial in P2. Pivot in every row gives us span, that gives us existence. Pivot in every column gives us uniqueness. So the other thing that we know about this, since there's a pivot in every column, since the columns of A are linearly independent, that means that T of x equals 0, the homogeneous equation, has only the trivial solution. So that's something else we get from column. So we also get that the columns of A are linearly independent. These particular pens on this particular surface have a speed limit. I can't just, I gotta kind of go slow. Otherwise it gets all dotted and stuff. So A has a pivot in every column, so the columns of A are linearly independent. And that means AX equals 0 has only the trivial solution. So the only part is critical. And when you say that AX equals 0 has a trivial solution, it always has a trivial solution. The question is not, does it have the trivial solution? The question is, are there non-trivial solutions? So when we say AX equals 0 has only the trivial solution, that's what it means when the columns of A are linearly independent. So this also means for the transformation that T of X equals 0 has only the trivial solution. That means that the kernel of T is just the 0 vector. Because the 0 vector is the only thing that maps to the 0 vector, because the transformation is injective. Because the matrix of the transformation has a pivot in every column. So there are a lot of equivalent things that are running around on when we say that A has a pivot in every column. It would be inappropriate to say something like T is injective because the columns of A are linearly independent, because I still get to ask, how do you know that the columns of A are linearly independent? You wouldn't want to say that the kernel of T is equal to 0 because AX equals 0 has only the trivial solution, because I get to ask, how do you know that AX equals 0 has only the trivial solution? It'd be inappropriate to say that the kernel of T is 0 because T is 1 to 1, because then I get to ask, how do you know that T is 1 to 1? The reason that we know all this is that we see that the standard matrix of T has a pivot in every column. It's the pivots that tell us these things. This is the same complaint that I had when y'all were using those rank arguments, which are perfectly valid, but you have to tell me how you know all this rank information. And the rank information comes from the pivots. So might as well use the pivots as your explanation. Also, we don't want to grab snippets of things and start editing down the things that we need to say. So instead of saying AX equals 0 has only the trivial solution, you try to say it a little bit shorter and you drop out only, and that's a critical word in this explanation. AX equals 0 has a trivial solution. That's like, yeah, of course. AX equals 0 is always consistent because it always has at least the trivial solution. Does it have any others? That's the question. So you don't get to edit out that word only. That's critical. Homogeneous equation has only the trivial solution. Now the columns of A are linearly independent. But once again, the reason that we know that is that we saw the matrix and we saw that there is a pivot in every column. T is onto because the matrix of T has a pivot in every row. That's how we know. Your explanations should pretty much always go back to pivots. Then you just have to work out not using the phrase the matrix or referring to matrices that you've never defined. So if you just wrote, here's the standard matrix of T, and then you start referring to the matrix A without ever saying A is equal to the standard matrix of T, without telling me specifically what you mean by the matrix A, I don't know what you're talking about. Even though I know exactly what you're talking about, I have to pretend like I don't. So I go, oh, you're using this matrix A. What is matrix A? And so I start looking through your work to where you defined what matrix A was. I know this makes me a huge jerk when it comes to grading, but you don't get to use undefined terms. And usually when I make a comment like that, when I say something like what equation or what matrix, I'm not asking you to write more. I'm probably asking you to write less. Because in your explanations, I want you to write as little as possible, but as much as is necessary. Any questions? So if I pick a vector in R3, then I should be able to find a polynomial that maps to that vector. And there should only be one of them. So let's try that. Let's pick a vector in R3. Uh-oh. I bet you thought class was going to be over because I was out of pages. Unfortunately for our heroes, I have many pages left. And I can talk for a very long time.
Do the QR codes keep things in order for you, or is it just for orientation?
I'm not sure. I think it's just for orientation because as far as just a quick inspection set, they all look the same. I think it's just for, there's also places that I could mark down here. You probably can't see them, but I can mark this to be sent to different locations upon scanning. So there's like a little bell, a little star, a horseshoe. So I can have it sent to a bunch of different places just by like putting an X through one of those little locations. So I think it's for locating things on the page.
DVD bonus material.
Also, inadvertent advertisement for Rocket Books, the reusable notebooks. Let's see, go with 5, -4, 1. So I want to solve an equation, but the solutions to my equation are going to be polynomials. But I'm going to do this using coordinates. So first I'm going to find the coordinates of P, and then I'm going to turn those coordinates into a polynomial. So that's an important thing to note. On coordinates 2, the quiz, well, it sounds like a movie, coordinates 2, the quiz. On coordinates 2, the quiz, problem 3, you were looking for a polynomial. So y was not equal to -5, 5, 4. That's a vector. I'm looking for the polynomial whose coordinates are -5, 5, 4. So what we're going to do is we're solving an equation, so I'm going to make an augmented matrix. Oh, now I got to find, oh, it's on the last page. At least it'll be easy to find. So I can't remember what I did. I usually do 0, -1, 2. Looks like that's what I did. Definitely in a rut. So now I'm going to try to find the coordinates of my polynomial. So it's going to modify the last thing I did. I'm going to insert, comma 5. Next row, I will insert, comma -4. Last row, insert, comma 1. You end up with fractions if you do things randomly. That's just a reality. So the reduced echelon form, I got the identity matrix. We knew that was going to happen. But the interesting part was the 5, 16/9, 16 thirds, -11 thirds. So we end up with 1, 0, 0, or 1, 0, 0, 0, 1, 0, 0, 0, 1, 5, 16 thirds, and -11 thirds. This all works the same way. Well, let's mark the pivots. We knew where the pivots were, but I want to circle them. I'm trying to emphasize the fact that the pivots are part of the matrix. Now notice that here we are looking at an augmented matrix. This is the only time it's appropriate to say rightmost column. And that's only when we're trying to determine if some equation is consistent. First of all, here's the equation that we're trying to determine is consistent. Here's the augmented matrix. of this equation. And the augmented matrix of the equation does not have a pivot in the rightmost column. Therefore, the equation is consistent. We do not want to say things like the matrix does not have a pivot in the rightmost column, because now I have to figure out what matrix you're referring to. But at least we get to say equation because the problem itself defines an equation. Everything else works the same. I've got a C1, a C2, and a C3. C1 is equal to 5, C2 is equal to 16 thirds, and C3 is equal to negative 11 thirds. Notice that we did not get any free variables. We did not expect any free variables because the standard matrix of T has a pivot in every column. We're going to get unique solutions. So there's only one polynomial that will result in 5, negative 4, 1. And that's P of T is 5 plus 16 thirds T minus 11 thirds T squared. Because T maps P2 onto R3, we knew we were going to get a solution. Because T is 1 to 1, we knew we would get exactly one solution. Existence is a row question. Uniqueness is a column question. So notice that if we plug in 0, we get 5. If we plug in negative 1, we get 5 minus 16 thirds minus 11 thirds, which is negative 4. And then when we plug in 2, we get 5 32 thirds plus 32 thirds minus 44 thirds, which is 1. Full disclosure, I didn't actually make those calculations. I'm just hoping that they worked out because that's what's supposed to happen.
It's arithmetic. It's okay.
All right. I'm not very good at arithmetic. It's not my strong suit. I got to say this. So I don't know what your friends group is like, but I have the most mathematical credentialing in my friends group. That's the important part. It's just mathematical credentialing because I have a master's degree. But the problem is, if we go out to dinner, everybody hands me the bill. So it's like 4 of us, we go out to dinner. And well, back in the days when you could do something like this, we would go out to dinner sitting around a table, not just like through Zoom where we all order the same pizza, even though one of us doesn't like this particular pizza. And like, oh, I don't want to order that pizza. It's like, well, forget it. This is what we would be ordering if we were in person. So you have to order this pizza that you don't like. Just pick off the stuff that you don't like. I'm just kidding. That's not how we do this.
Damn.
We ordered for them so they wouldn't mess it up. I'm just kidding. So the bill comes, and there's 4 people, and the bill, including tip, is going to be $100. And then they hand the bill to me, and I'm like, all right, everybody pitch in $33.33. And they go, hang on a second, shouldn't that be 25? And I'm like, oh no, you forgot tax and tip. And for the most part, that just works on my friends because I have mathematical credentialing and therefore authority. But then when they're like, oh, no, we've worked it out. There's 4 of us. It's $100. 100 divided by total, 100 divided by 4 is 25. I'm like, you forgot my consulting fee, which is, unsurprisingly, $25. So basically, if the bill, whatever the bill is, if there are n people eating at the table, then my consulting fee is 1/n of the bill. That's the way it works. And then when they complain about that, I'm like, oh, look, if you didn't want to pay a consulting fee, don't hire a professional to divide by 4. You just demonstrated to me that you could do the math. Why did you ask me to do it? I mean, y'all can do math as a hobby. You do the math. I'm a professional. I don't do this for free. But then secretly, I don't do arithmetic for free because I'm not really good at it. I don't even do arithmetic for pay. I'm not very good at arithmetic.
The best part is you can just take all the cash and expense the meal.
That's right. That's right. I should just always put on my credit card and then just write off every meal that I go out. Because just make sure everybody asks you to divide by 4. Or the number of people at the table. I've also noticed that my friends group kind of has, this is how you know if your friends group has enough money. When you go out to dinner, however many people are there or however many couples are there, first of all, you're dividing by couples instead of by people. That's the first indication. And the second indication is that everybody is cool with just dividing by the number of couples. Whatever the bill is, just divide by that. No one's like, oh, but I only had a salad. First of all, because in my friends group, no one ever just has the salad. But we don't keep track of like, oh, well, Jim had like 4 drinks and I only had like 2, so he should pay more. We just like, you know what? It'll all work itself out in the end. So at one point we discovered that we could do that and we were all okay with it. So we just high-fived each other that we have, clearly we have enough money. So we were happy. You know what I mean? But definitely in the college days, it'd be like, I only had the chips and salsa and 1 margarita and like a bite of everybody else's food because I'm broke. So there was definitely times like that where you do care if someone just ordered the salad. Then you can find the rich kid in the friends group. He's like, well, let's just divide by 4. And you're like, well, hell no. You had the steak and lobster. I ain't subsidizing your steak and lobster habit. Second of all, steak and lobster is a disgusting meal choice. What's wrong with you? Freaking gluttony. You know what I'm talking about? Oh, shoot, I'm recording. So anyway, for all of those out in YouTube land, become a professional mathematician, then you won't have to pay for dinner anymore. It's all consulting fees. Now, if you do hang out with a bunch of engineers, they're going to notice. In my D&D group, one of the members of the D&D group is an accountant. So their arithmetic, I might know more math, but their arithmetic skills are far superior to my own. So I don't get to run that game on that guy. Oh well. So let's pause the video here and see if there's anything else we need to talk about.